and then reduce that. Reduced. 5 to 2. Very good. DI has a measure of 10. IS has a measure of 4. So if I take 10 to 4 and reduce it, the ratio is 5 to 2. Yep. Okay.
Wait, how?
I'm not erasing it. I'm just erasing the little reds.
Did you pick up our assignment number 12? I don't know what mine is.
Yeah, I have it.
Oh, okay, good. I was freaking out.
All right. Now find the ratio of ST to DI. Remember, it must be in lowest terms.
Oh, Miss Dime. You're ruining it for everybody, Nick.
He's excited.
Wait, 10 to 4 is for which one is on?
DI to IS. Next, we're going to look at ST to DI, and Nick says that the ratio is 6 to 5, and he is absolutely correct. Because ST has a measure of 12, DI has a measure of 10, and when you reduce this to lowest terms, you get 6 to 5. All right?
Why does the marker follow you around?
I have no idea.
Wait, what is the 5 to 2 for? That's for the first one.
Lowest terms.
Okay. I got you.
I have a little fly flying around in here.
It was on my desk earlier.
Maybe just on my
It's too slow.
I have it. I'm going to give it back to y'all. Oh, okay. No, I didn't pick it up then. I picked it up from the last hour. IT to DT.
Oh, I did it. 47.
Wait.
Nick is correct.
8 to 13. Wait, can everyone? Man, I'm losing my mind.
IT has a measure of what?
16.
16. DT has a measure of
10.
26. DT is the whole thing. 10 plus 4 plus 12. And 16 and 26 can both be reduced by 2.
8.
Which is how we get 8 to 13.
Golly, Nick's a genius.
Okay, I got the next one. All right. Now, we want the ratio of 3 lengths, which means when you go to reduce it, all 3 numbers have to be reduced by the same number. Okay?
Don't say it, Elise.
Hold on, let's let everybody get it. At least you can answer it. Nobody else answer it. Give her her shining moment in the sun.
The answer is. Miss Allen, I wasn't here Friday, and then you weren't here Monday, so I didn't give you my excuse, but it was an excuse.
Okay. All right, Elise, what is it?
2 to 5 to 8.
You are correct.
What?
You want to solve it or?
What?
There's nothing to solve. You're just reducing.
Is Katie done?
IS is 4. Haven't talked to her today. DI is 10. IT is 16.
Oh.
Yep.
Oh.
4, 10, and 16 all reduced by 2. Give us 2, 5 to 8. Yes.
So you only solve it when you can't reduce it? When you have 3?
What you mean solve it?
Like with the x's, and it's equal to 1.
That's the
and you-
problem.
If you have an X in there somewhere and you can set up an equation, then you solve it. Okay?
You solve that.
But here we're not really solving anything.
We're just finding a
We're just finding it.
We're just finding a ratio. Okay? We're going to get into solving stuff later. If I ask you to express this ratio
7, 5, 0.
in simplest terms,
Add 3 placements to liters. Wait, y'all are too bad.
I have a problem. I'm comparing milliliters to liters. I'm going to change liters to milliliters by doing what?
Moving it 3 places.
Moving it 3 places.
To the right.
Which means I'm multiplying by 1,000.
Wait, what was the
Because there are 1,000 milliliters in 1 liter, and I'm going from big to small, so I multiply by that factor.
Yeah, I really have one real hard.
Small to big, you divide.
How does the show divide?
Because
You're
you're
two
taking apart multiplication. This is the division symbol, and my head is the dot at the top.
Repeat it at the bottom.
Sorry, we cannot.
All right. What's this reduce?
You can knock off a 0 and make it 75.
And Jemima, divide by 25. Or a lot more than that.
Well, you'd eventually get there.
I'll divide by 75.
Whoa.
Think about anytime you're dealing with 25, 50, 75, 125, 150. Think of money. Think of quarters. That's how I always do it.
That's all I just pretend check.
Okay?
Yeah, money.
1 to 2 is that ratio.
Always cooking.
Is it possible to express a ratio comparing liters to kilometers?
No, it's a person and a bus.
There you go.
Well, you could do a person and a bus. I mean, like time and a bus.
Right, okay. One is talking about volume, while the other one is talking about distance. Okay.
Oh, we
So-
got a problem.
You can't put this as a ratio. It's impossible to compare.
Yeah.
And that's as low as you can do it, because it's 1.
I didn't get to ask my questions yet. Y'all need to be quiet. Thank you, though. If I told you that there are 3 numbers that are in a ratio of 1 to 2 to 5, and we don't know what those numbers are, and I said, could the numbers be 1, 2, and 5? Your answer would be,
Yes.
well, yes, because that's a ratio of 1, 2 to 5. Could the numbers be 2 to 4 to 10?
Yeah.
Yes.
If I multiply all of those by 2, that gives me 2, 4, 10, right?
Right.
Could they be 100, 200, and 500?
Yes.
Yeah.
Could they be 3, 6, and 12?
No.
No.
No, because 5 times 3 is 12.
Exactly. Okay? So we need to understand how we get into and out of ratios. All of those numbers need to be increased by the same multiple or decreased by the same multiple. Otherwise, it's not a proper ratio. All right, this is an intro into tomorrow, but we need to talk about for a second a proportion. A proportion is 2 ratios set equal to each other. And this is where we're going to really get into solving when we're looking at our similar polygons. Because we're going to establish, all right, these 2 polygons are in a ratio of 1 to 3. So if this side is equal to whatever, then what's this side? And we do that by using what we call a proportion. This is a proportion. 1/2 is equal to 5/10. Do you agree with me?
Yes.
Yes.
When you're working with proportions, you will find that the product of the means, which would be the 2 inner terms, or the 2 that you wrote second and third, is equal to the product of the extremes. When I multiply those things out, is that true?
Yes.
Then yes, it is definitely a proportion. If it's not true, it's not a proportion.
So B times X equals A times 1.
Exactly. Okay? Now, how are we going to use this?
So X equals.
We're going to use proportions to look for missing pieces. X would have to equal 12. You are correct. Because using our property of cross multiplication, 1 times x is equal to 3 times 4.